Today we learn pointers. So it is a part 2. It covers advanced portion of pointers. That is pointer to pointer, then array of pointers, function returning pointer. So it cover advanced portion of pointers. So array of integer has collection of integer value. So ordinary array variable can store collection of integer value. Integer array can store integer value, but integer pointer array can store address of integer variable. So ordinary array can hold value. Pointer array can store address. So integer star of a. So integer star of a, it allocate 4 locations. But this is a pointer variable. It is a pointer array or array of pointer. A is a pointer array. It has 4 locations. Each location can capable to store address of integer variable because it is an integer type pointer array. So a of 0, a of 1, a of 2, a of 3, it allocate 4 locations. Each location 2 bytes because it is an integer, because it is a pointer. It may be a float pointer array. Each location has only 2 bytes. Double, float, it may be any data type. If, all pointer variable size is 2 bytes. So each location 2 bytes, that is 200, 202. The first location address, 0th location address, we assume 200, 202, 204, 206. Then we declare and initialize I equal to 31, j equal to 5, k equal to 19, l equal to 71, m. So this is a memory mapping for ijklm. ijkl. So I is 31. So it also has some address. Each and every variable has some address, 500, 700, 300, 800. These are the address. In this line, AR of 0 equal to and I. 0th location, first location, second, third. So each location can capable to store address of integer variable. So here we assign address of I. So I is integer variable, we assign the address of I. What is the address of I? 500. 500 is assigned to AR of 0. Address of j, that is 700 is assigned to AR of 1. Address of k, 300 is assigned to AR of 2. Address of L, 800 is assigned to AR of 3. That is 500, 700, 300, 800. In the for loop, here we use the variable, we initialize 0, then we compare with the condition is true. 0 less than or equal to 3, condition is true. So AR of m, to display ARR of m. So what is the value of m? M is 0. AR of 0, it display AR of, what is the AR of 0? 500. Star of AR of m, that is value at 500. Value at 500, 31. Just AR of m, the m value is 0. AR of 0 is 500. Star of 500, value at 500. Value at 500, 31. It display 31. Loop continue. The value m is increased by 1. The new value is 1. So AR of 1. What is AR of 1? 700. Star of AR of 1. That is value at 700. 5. So it increased by 1. M value is 2. Then AR of 2, 300. Value at 300, 19. Then 3. AR of 3. AR of 3 is 800. And then value star of 800, 71. So it display 531 in the first time, first loop. And the next repetition 705. There's a second, third one 319, 871. So m is 4. The condition is false. It comes out of the loop. Then it terminates the program. So this is an individual variable. IJKL are individual variable. It is a separate variable. It does not have continuous memory allocation. So 500, 501 for I. So j is a different address, k is different, l is different. It is not continuous address location. Suppose if we want to access the value, we put separate percentage accessing value, mean that is if we want to display the value. So we need to get individual variable. We access individually because it does not have any continuous memory allocation. It has that is it is a different memory allocation. It does not relate with other variable. But after assigning that variable addresses into the pointer array, so 200, 202, 204, 206, these are the continuous address. If we take 200, then we can easily move to next location, then next, then next. So if we want to store the different location address into a pointer array, we can have the continuous accessing. So limitation of array of pointers to string. If we want to store a string into a pointer array, for example, if 2-dimensional array, we are using 2-dimensional array to store the string. That is static character n of 520. So it is a 5 rows. Each row has 20 columns. It's a character. So each row 20 bytes. Then 0, that is n of 0. N of 0, 0, n of 0, 1, n of 0, 2. So the first row, the green, the character, the string is assigned in first row. Second row, blue. Third row, yellow. Fourth, orange. Fifth, that is, it starts 0, 0, 1, 2, 3, 4. So n of, we can easily assign in by using 2-dimensional character array, we can assign string. It is possible. We can get input like that. That is, at the time of declaration also we initialize. First we declare, then we can get input through keyboard. This is also possible. So we can initialize and we can get input through the keyboard. But if we are using array of pointers to string, we can initialize the string at the time of declaration, but we cannot receive the string from the keyboard using scanf. In 2-dimensional character array, we can initialize at the time of declaration and also we can get the input through keyboard. But in pointer array, character pointer array, we can initialize at the time of declaration. We cannot able to get input through keyboard. So these are invalid. Character star p of I. So after that we get input, because each and every location of p array can store address of character. But we cannot able to get input. This is invalid. Through character pointer variable, we can initialize like character star of p of I. At the time of declaration, we can directly initialize green, blue, yellow, orange, red. It is a valid one. P of 0 has only 1 byte or 2 byte. P of 0 is 2 bytes because it is a pointer array. All kind of pointer array has 2 bytes. All data types, it may be any kind of data types. The pointer array allocate only 2 bytes. It may be independent of data types. So that P of 0 is a 2 bytes because it is a pointer location. So it can store address of string. So the green is stored in anywhere in the memory. The starting address is assigned to P of 0. Blue is assigned anywhere in memory. The starting address of blue is assigned P of 1. And similar way P of 2, P of 3, P of 4. So all are assigned. This is a valid, but this is not a valid. So if we declare 2-dimensional array to handle the string, if we want to get input or assigning, so we use 2-dimensional character array to assign the values. We cannot able to get the value for pointers. So only two point is there. One is in 2-dimensional character array, we can initialize at the time of declaration. It is also possible. We can also get string through keyboard. So in character pointer array, at the time of declaration, we can initialize. This is valid, but we cannot able to get string through keyboard. Then pointer to pointer. Pointer variable can store address of ordinary variable. So pointer variable can store address of a variable. Pointer to pointer variable can store address of pointer variable. If we want to assign the address of a variable, we create pointer variable. If want to store address of pointer variable, We want to declare pointer to pointer variable. So pointer variable can hold address of ordinary variable. Pointer to pointer variable can store address of pointer variable. So for example, integer a equal to 25. This is a location name. The value at location 700 is the address of that location. Next line, integer star b equal to ampersand symbol a, that is and a, that is address of a. What is address of a? 700. 700 is assigned to b. B is a pointer variable, so it can hold address of integer variable. So here we assign integer variable address to b, so that 700 is stored as address. That is, it is point the a. In this line, b is a pointer variable, the address of a is assigned to b, so it's point that location. 700 is assigned here, so it point that location. So then only it called as pointer variable. So pointer variable, point variable, location of variable, pointer variable, point location of variable. Next line, integer star c equal to ampersand symbol b. B is a pointer variable. B is a pointer variable. Pointer variable is also has two bytes, but it has address. So 800, 801. For processing purpose, we take the starting byte address, that is 800. That 800 is assigned to c. C is a pointer variable. Is it possible? Because b is a pointer variable, c is also a pointer variable. We assign the address of pointer variable to a pointer value. If we try to assign address of pointer variable to pointer variable, it convert address 800 as ordinary variable. So that 800 is not a address of pointer variable. It convert as ordinary address of ordinary variable, because c is a pointer variable. It can hold only address of ordinary variable. It cannot able to hold address of pointer variable. If we try to assign the address of pointer variable, it convert as ordinary variable address. So here 800 is a ordinary variable address. Integer double star d. If we put double star before the variable, this is a pointer to pointer variable at the time of declaration. If we put a double star before the variable, this is called a pointer to pointer variable equal to and b. Here we assign address of b into pointer to pointer variable. Pointer to pointer variable can store address of pointer variable. Pointer variable can store address of ordinary variable. Pointer to pointer variable can store address of pointer variable. B is a pointer variable, so we can store address of b into pointer to pointer variable. Now in here 800 is a address of pointer variable, but here 800 is a address of ordinary variable, because c is a pointer variable. It's not a pointer to pointer variable. We try to assign address of pointer variable into pointer variable. That receiving pointer variable converted it into ordinary variable address. So we should assign the address of pointer variable into pointer to pointer variable. There is an example program for pointer to pointer variable. Integer a equal to 55, star b star double star d. B is a is a ordinary variable, so it hold 55. Star b is a pointer variable. The size is 2 bytes. Pointer to pointer variable is also 2 bytes. So pointer variable or pointer to variable all are in the size of pointer variable or pointer to pointer variable is 2 bytes only, independent of data types. So a equal to and a equal to b equal to and a. It is a typo. B equal to and a. Address of a is assigned to b. This one is b. Address of a is assigned to b. So assume the a variable a address is 700, b address is 800, d address is 950. Just we assume that b equal to and a. B equal to and a. Address of a, that is 700 is assigned to b. D equal to and b. The address of b is assigned to d. Address of b is 800. For example, it is a 700. The address of A is 700. This address is 800. This address is 950. So here we assign address of A, that is 700 into B. Then address of B assigned to D. Address of B is 800. 800 is assigned to D. D can hold address of pointer variable. B is a pointer variable because D is a pointer to pointer variable. So it can store address of pointer variable. Percentage D, 3 percentage D and A and B and D. So what is address of A? As per our example, and A is 700 and B 800 and D is 950. The next line, just we put A. If we put A, it display 55. What is the B? B equal to and A. That is address of A is stored in B. Just B, it refers to 700. If we put star, valued 700, valued 755. What is the D? D is 950. Just D is 950. That is, it is stored the address of B. So 950 star B, valued 950 is 800. Another star, valued 800. Valued 800 is 700. So it display 55. So the three variable give 55, 55, 55. If we want to get the value, we put double star. If we want to get the value from pointer to pointer, we put double star. Pointer to function. So if we want to store, each and every function has address. Function is also has address. A function can also call by using address. So here we each and every variable has address. We assign that address into the appropriate pointer variable. Then we can get the value through pointer variable. In pointer to function also, the function also has the address. We can call by using address. A function has address. We can store that address into a pointer to function variable. A pointer to function variable is store address of function. A pointer variable is store address of variable. A pointer to pointer variable is store address of pointer variable. A function pointer variable or pointer to function variable is store address of function. So pointer to function variable can store the address of function. The function can call by using pointer to function variable. So by using pointer to function variable, we can call the function. So this is the function pointer variable declaration, that is pointer to function. If you integer, if you want to store the address of integer type function, if your function return an integer, so we can store that address in integer function pointer variable. So int star fun para parenthesis. This fun is a pointer to function variable. This variable can store address of function. That function should be written integer. So that's why we here give integer type. Int star fun. So fun is a pointer to function variable. It can store integer type function. This is a function pointer variable declaration. Function pointer variable also called as pointer to function. So this variable can store address of function. The example program to pointer function. Integer display. So display is a function. So by default all function are integer type function. So it is not necessary here. Int display is not necessary because all functions are integer type. Other than integer, we must declare that. So integer display int within a parenthesis star fun, then followed by para parenthesis. This is a pointer to function variable. It is a pointer to function variable. It can store address of function. Then in next line, fun equal to disp. If we put disp followed by para parenthesis, it calls the function, then return some value. If you put parenthesis, it is a function call. If you remove the parenthesis, it return address of that function. If you want to get the function address, if you want to get address of function, just we put function name without parenthesis, without parenthesis. Display is a function, just we put this. So it will give address. That address is assigned to fun. Fun is a function pointer variable. So it can hold address of integer function variable, integer function. So disp return address of that function. That address is assigned to fun. Printf address of the function disp is percentage disp. If we put like this, so that disp is give address of that function. For example, 1200. Address of the function disp is this statement display like this. It get address. So all address are in integer format. So we put percentage d. So it display 1200. Then here we call the function through pointer to function variable. We are simply call, that is by using name disp followed by parenthesis semicolon. This is a normal function call. But here we are invoke the function display through pointer to function variable. By using pointer to function variable, we call this function. So the control is transferred here based on the address, because fun has address. Fun has address. That address is assigned. The display function address is assigned here. So using this address, it called the function. So I am in disp function. Then control is transferred here. It terminate the program. So this will be the output. Address of the function disp is 1200. I am in disp function. So this is a function pointer variable. This is a function pointer variable or pointer to function variable. That pointer to function variable can store address of function. So this is the way to get the address of function. Just we remove the parenthesis after the function. The function name, just we put the name only. We remove the parenthesis. It will give the address. That address is assigned to function pointer variable. By using the function point variable, we can invoke the function display. Function returning pointer. Normally function return integer. By defaultly function return, all functions return only one value. But the default return type is integer. If you declare or not declare, it return integer. If we want to return float or double, we must declare the function. Otherwise it return integer value only. But we are also return the pointer. What is pointer? We can return the address of a variable. We can return address of the variable. Integer star p, integer star fun. This is a function declaration. Because defaultly all functions are written integer value. But in our example, that function must the function want to return address of variable. So address of integer variable. So here we declare like, we remove the star int fun. So the fun is a function, it return integer value. If we put int star fun, fun is a function, it will return address of integer variable. So p equal to fun. This one is a function call because the parenthesis is there. So it is a function call. It called the function. Here also we put star. At the definition also we put star. If you remove the star, it will return a value, not address. So integer star fun. Then integer I equal to 20. So I has 2 bits. The value 20 is assigned to I. The address is 900. So it return address of I. So 900. It return integer address. So it is an integer pointer type function. So it return address of I. That is 900 is written here. That 900 is assigned to p. 900 is an integer address. P is also integer pointer variable. So we can assign that 900 to p. Percentage d p star p. What is the p? P is 900. Display 900. What is p? Star p. Value at 900. Value at 900 is 20. Value at 900 20. So display 920. So we can return the address. We can return address. Here we return address. So this is function returning pointer. Function with variable number of arguments. So we can call a function by passing different number of arguments. For example, Find max is a function. Here we pass 6 values. Here we pass 6 values, but we call find max. Here we pass only 4 value. So we can pass variable number of arguments to the function through 3 macros. A function defined to pass variable number of arguments. In previous sessions, we call function fixed number of arguments only. If we call more than one time, first we define to receive 3 arguments. At the time of calling, we pass 3 values. So we cannot able to change that number of arguments. But by using 3 macros, so we will discuss the next session about the macros. So VA list, VA start, VARG is the macros. By using this macro, we can pass the different number of arguments to a same function. So like find max, it pass 6 arguments. Here it pass only 4 arguments. So these 3 macros as defined in stdarg.header. So we must include that header file. Main integer max, it is an integer variable. Then max equal to find max is a function name. These are all the arguments. 5, 23, 15, these are all the arguments. Just we call the function by value. So this is the definition for that function. Find max is a one variable. It is a receiving area. This one is a actual argument. This is formal arguments. So to receive only one variable is there. Here we pass 6 values. So it pass only 5 to total number. So total number is 5. In this case, it pass only 5 because only one variable is there. So the total number value is 5. Integer max count num. It is a local variable. Here we declare one variable. VA list PTR. We must declare. This is the 3 steps. By using this macro, we declare one variable. This is a VA list variable. We can give any name. PTR is not fixed one. It is a user defined. We can give any name. Here it is a PTR. VA list PTR. Then VA start. This is another macro of stdarg.h. So PTR comma. So the first argument of VA start macro, the PTR is a VA list variable. What is a VA list variable? PTR is a VA list variable. So PTR comma. Here we give total num. This variable. What is the value of total num? In this case, total num is 5. So PTR comma 5. So it internally find the 5 values. So max equal to VA. Max is an integer variable. That is local variable. VA ARG PTR comma INT. This is also max. In main function also has one variable max. In find max function also one has max as an integer variable. But this location is differ from this location. This has individual location. This max has individual location. So max equal to VA ARG. This is a third macro. Within a bracket PTR comma int. If we want to get integer value, if we want to handle integer value, here we put int. If we want to get float value, here we put float. So in this case, we want to get integer value. So here we put int. This is a PTR. PTR is a VA list variable PTR. Then VA start. We want to initiate the 5 locations. That is here we mention 5 locations. In this case, total num is a 5. Then VARG of PTR comma INT. So it get first value from that sequence. It get first value PTR comma INT because it is a int. It get 2 bytes value. So what is the next value? 23. 23. Here it get 23. It assigned to max. Now the max is 23. For count equal to 0, count less than total num is 5. Less than or equal to 5, count plus plus. Num equal to VARG comma PTR comma INT. So here also we are using VARG. It will get one value. That is next value from the sequence. That is 15. So it take 15 and assign to num. So now num value is 15. Then it compare max. What is the value of max? Max is 23, num is 15. 23 less than 15, condition false. So it continue the loop. Then it will get next number from that sequence, 1. So the 1 is assigned to num. What is the value of max? Max is remain 23. 23 less than 1, condition false. Continue the loop. Then it get another value from that sequence, 92. Now the value of num is 92. So max value remain 23. 23 less than 92. 23 less than 92 is condition true. So if the condition is true, num is assigned to max. What is the value of num? 92. What is the value of max? 23. So that 92 is replaced. The 92 is assigned to max. The 23 is replaced by 92. So now the value of max is 92. The loop will continue. Then it access next value of that sequence, 50. That 50 is assigned to num. So max is 92. 92 less than 50, condition false. It continue the loop. The condition, the for loop condition is false. It come out the loop. Then it return max. What is the value of max? 92. So it return maximum value of that sequence. So it return 92. So that 92 is assigned to, the control is transferred to main function. That 92 is assigned to max. It display max equal to 92. Then next statement, max equal to find max. Again we call the function, same function, but totally 4 arguments. That 3 is passed to totenum. The value of totenum is 3. So it create list. The list name is ptr. Then it start that sequence ptr comma totenum is 3. Then barg ptr comma int. So first it get 300. Then it is assigned to max. It rotate 2 times. Then 100. 100 is assigned to num. 300 less than 100, condition false. Then it take 29, assigned to num. 300 less than 29, condition false. It come out the loop. It return 300 to main function. That 300 is assigned to max. Max equal to 300. This is the output. By using VA list, VA start, VA argument, we can pass different number of arguments to the same function.